Hi. In this lecture, we will be discussing principle of dominance only, but with some special references. In our last session, we discussed n cross m games and we tried to solve by principle of dominance. Try to solve in the sense, try to reduce the matrix by using principle of dominance method. But that was a basic problem, right? Why it was a basic problem? Because during the solution, you could find a particular row which was dominating over a particular row. Similarly, we could find a particular column which was dominating over another particular column. But when this kind of situation does not exist, that means when a particular row or a particular column does not exist, which is dominating over a particular row or column, right? Such cases are considered as complex case. So let us try to see this. I'm not getting into this row rule and column rule because we are aware about it. So we have been given a problem. This is our problem where a firm which is making profit has four strategies, that is A1 to A4. Another firm which is making loss has four strategies, that is B1 to B4, right? And the values, payoff values are given to us. Now we know the thumb rule is to check for saddle point. So for each row, we have calculated our minimum value. So this is 0, this is 2, 0, and 0. And out of this minimum value, the maximum value is 2. So our maximum is 2. Coming to B1, for B1, we need to calculate our maximum values, which is 4 for B1. For B2 also it is 4. For B3 also it is 4. For B4 it is 8, right? So the minimum among these maximum values is 4, right? Now see, our maximum is not equals to our minimax. Maximum is 2 and minimax is 4. So therefore saddle point does not exist, right? Now it means it's a game of mixed strategy. Now since it is a game of mixed strategy and it has 4 rows and 4 columns, that means it belongs to n cross n game. Now we know n cross m game can be reduced by principle of dominance. So we are applying principle of dominance, right? So let us go further. See, we found all the values of A3 is greater than or equal to corresponding values of A1. See, A3 is 4, 2, 4, 0. Let us compare A3 and A1. 4 is greater than 3. 2 is equal to 3, 4 equals to 4, 0 equals to 0. That means all the values of A3 is either greater or equal to the corresponding values. That means A3 dominates over A1, and since A3 is dominating, we don't require A1 in the matrix. So we have eliminated matrix in our reduced form, right? So now the matrix has A2, A3, A4, B1, B2, B3, B4. Now since we have done row operation, let us go for column operation now. It says all the values of B3 is less than or equal to corresponding values of B1. Say we are comparing B3 and B1. So B3, 2 is less than 3. 4 equals to 4, 0 equals to 0. That means all the values of B3 is either less or equal to the corresponding values of B1. That means B3 dominates over B1. So we don't require B1 now. So this is a reduced matrix. Fine. Now let us try to compare. See, I have written over here, there does not exist any row which satisfies row rule of principle of dominance. Let me check that. Let us compare A2 and A3. 4 is greater than 2, but 2 is less than 4, right? So a rule does not exist. 4 is equal to 4, 2 is greater than 0, but 4 is less than 8. That means A2 and A4 also does not satisfy the condition. Let us compare A3. 2 is less than 4, but 4 is less than 0. Again, it's not satisfying the rule. That means there does not exist any individual row which can satisfy the row rule. Coming to column, let me compare B2 and B3. 4 greater than 2, but 2 less than 4. So there does not exist the rule. 4 is equal to 4, 2 is greater than 0, but 4 is less than 8. Again, it is not satisfying the rule. B3, B4, 2 less than 4, but 4 greater than 0. So again, it's not satisfying. So neither we found a row or column which satisfy the rules of principle of dominance, right? But we need to give a solution to this, because with 3 cross 3 matrix, you cannot solve a game, right? To solve a game, you have to reduce it further, right? And since it is a practical problem, that means it need to have a solution. So what we did is, we observed all the values of average of B3 and B4, right? Take B3 and B4 together and take the average. For example, 2 plus 4 is 6 divided by 3, divided by 2. That means the value is 3, right? I'm taking the average. So 2 plus 4 is 6 divided by 2 is 3, right? So 3 is less than 4. 4 plus 0 divided by 2 is 2, which is equals to 2. 0 plus 8 is 4, which is equal to 4, right? That means if we take together these two columns and take average, we find that the average values are either less or equal to the corresponding values of B2. So that is what has been written. All the values of average of B3 and B4 is less than or equal to corresponding values of B2. That means that average column is dominating over B2, and that average column is being determined by taking average of B3 and B4. So B3 and B4 together dominates over B2. So we don't require B2 now, right? Because B3 and B4 club together and it is dominating over B2. So we have eliminated B2 in our reduced matrix. Therefore, the reduced matrix is this. Fine. Now, also all the values of A3 and A4. Now, since we have done a column operation here, so we will be doing a row operation here. All the values of average of A3 and A4. Let me take A3 and A4 average. 4 plus 0 is 2. 0 plus 8 is 4. So both are equal to A2. That means we can say A3 and A4 together dominates over A2. So A3 and A4 together dominates over A2. Therefore, the reduced matrix is this, right? Now observe, you have reduced it to 2 cross 2 matrix. 2 strategies for A and 2 strategies for B, right? Since the matrix is reduced to 2 cross 2 matrix, therefore odd method will be applied, right? So I'm not getting into the solution of this reduced matrix now. You can refer to the lecture specifically dedicated for odd method, right? So this was a special case where we did not find an individual row which was satisfying the principle of dominance. So what we did is we tried to look for two rows or two columns, average of which is dominating over another column or row, right? And finally we reduced. In the same context, we'll try to see another problem. It is again a special case, right? That means we will not be finding an exclusive row or column which dominates over other row or column. So we need to look for average here also, right? But the treatment will be a little different in this case. Let us try to see. See, we have been given a problem. Again, we have 4 strategies for A and 4 strategies for B, right? And these are our values. So as a thumb rule, we are taking the row minimum, that is 5 minus 4, 0, minus 2. So the maximum of this minimum value is 5. So maximum is 5. Next, for columns, it is 10, 6, 9, 10, and the minimum of this maximum value is 6. 6 is not equals to 5, right? That means saddle point does not exist. And since it is a 4 cross 4 matrix, so principle of dominance will be used further. Now let us try to start with a row. We found out all the values of A1, that means these values, greater than corresponding values of A3. So we compared A1 with A3. See, 7 is greater than 3, 5 is greater than 0, 8 is greater than 4, and 9 is greater than 2. So what was our condition? The row values has to be either greater or equal. Now in our case, it is greater, so it satisfies the condition. That means A1 dominates over A3. So we eliminated A3 and we reduced matrix in this. Now, in the reduced matrix, all the values of B3 is less than corresponding values of B4, right? 8 is less than 9, 9 is less than 10, and 2 is less than 0. That means B3 dominates over B4, correct? So we eliminated B4 from our matrix. Coming down. Now see, like the previous case, here also, there does not exist any row which satisfies row rule. Let me check. 7 is greater than minus 4. 5 is greater than minus 3. But 8 is less than 9. That means A1, A2 could not get into the condition. Let me compare A1 and A4. 7 less than 10. 5 equals to 5. But 8 greater than minus 2. So again, A1 and A4 cannot form the condition. A2, A4, minus 4 less than 10, minus 3 less than 5, but 9 greater than minus 2. So there does not exist any row which can dominate over other. Similarly, there does not exist any column which can dominate over other. Right? Compare 7 greater than 5, minus 4 less than 3. 7 less than 8, minus 4 less than 9, but 10 greater than minus 2. Similarly, if we compare B2, B3, 5 less than 8, minus 3 less than 9, but 5 greater than minus 2, right? So, what is to be done? We are supposed to give answer for this. So, let us try for taking the average, right? See, all the values of A1 is greater than the corresponding values of average of A2 and A4. That we take 10 minus 4 is 6 by 2 is 3. So 7 is greater than 3. 5 minus 3 is 2. 2 by 2 is 1. So 5 is greater than 1. 9 minus 2 is 7. By 2 is 3.5. So 8 greater than 3.5. That means values of A1 is greater than values of average of A2 and A4, right? That means this A1 is dominating over this average value, correct? So that is what has been mentioned. So A1 dominates over A2 and A4. So we don't require A2 and A4 as A1 is dominating. So it's only A1. Now see, we have reduced the problem into 1 cross 3 matrix because firm A has only one strategy now. So for this, you cannot apply your odd method. Odd method can be applied to 2 cross 2 matrix. So whenever this kind of form comes, you will be using saddle point method. Now see, for saddle point, what we used to do is we used to take minimum of row, so it is 5, and maximum of minimum, then again it is 5. For each row, with each column will be taking the maximum, so it is 7, 5, 8, and minimum of the maximum, so 5, 5, 5 equal. That means 5 will be chosen. A will apply strategy A1, B2 will apply B will apply B2, and value of the game will be 5. Right? So these are two different special cases which can appear during the solution of a game theory problem. Right? Hope you have understood the concept. For any further query, you can contact me on this email ID. This is in smaller case. Right? So thank you.